These are Unit 5 review videos. Please note the directions here at the top. For the entirety of this review, you must clearly indicate by circling, boxing, whatever it is you use, your final answer or answers to each problem. Failure to do so will result in a loss of credit, okay? So just, that's not rigid in the sense that you always have to do the same thing over and over and over, but please just make sure when you get done with the problem that the answer is easy enough to locate, okay? So here we are starting with number 1, solve each system by graphing. These first two are equalities, the next two are inequalities. The equalities are where we're looking for intersections. So we start with this first one, okay? I'm gonna start at +3. I wanna go up 5 over 1, but I can't, so instead I'm gonna go down 5, left 1, okay? Here's the only other dot that I can fit on here. And so I draw my straight line through them as best I can. This one's not so great. Close enough, okay? And then for my next one, I'll do this one in black. I'm starting at -3 here. I'm going, this is a -1 for a slope, which is -1 over 1. So I'm gonna go down 1, right 1, down 1, right 1, or I can go up 1, left 1. So there I can see the intersection point, up 1, left 1, and I draw a line through those points. Again, I could see the intersections actually right there. My red line was a little bit off. So that tells me my final answer is -1, -2. I like to box in my answers. You can use whatever you would like, star it, do something like that. But you would need to write out that point. Number 2 is a little bit more difficult because our equations aren't solved already. So this first equation is 2 minus y equals -1/4 x. I want y all by itself, slope-intercept form. So I'm gonna leave it sitting where it is right here. Some people like to move it to the right. That's what I would do personally. But I know most of my students, especially this year, like to leave y on the left-hand side, and that's fine. So we subtract 2 from both sides. I get -y equals -1/4 x minus 2. And then I'm gonna divide both sides by -1. That basically just flips all of my signs. So I get 1/4 x plus 2, okay? Took that negative and made it positive, took this negative, made it positive. That means for this blue line, I'm starting at +2, and I'm going up 1, right 4, okay? So right there. That means I can also go down 1 and left 4 to produce a line. For this equation, I have 4y minus x equals 8, so I'm gonna add x to both sides. That's going to cancel. I get 4y equals x plus 8. I write the x in front because, again, we're searching for y equals mx plus b, slope-intercept form. So I like the x to be written first. Then I divide by 4 on both sides. I get y equals. This is a 1x, so I get a slope of 1/4 x plus 2. So for this one, I'm starting at 2. I'm going up 1, right 4. Or down 1, left 4. We can see that it's the exact same line. That's one of those special cases. That means our answer is infinite number of solutions. Or infinite solutions. That's because you could pick an infinite amount of points. We see 3 already that work for both lines, and it would just keep on going. There's an infinite amount of points that would work for both of those equations that would solve to be correct. 3 and 4, here we're doing inequalities, and again, the equations start off easy on the first one. We don't have to do any solving. We just start here at -3, and this would be a 4 over 1, rise over run, go up 4, right 1, up 4, right 1. Now, I look at the symbol now to see what kind of line I need. Because this is not or equal to, I need a dashed line. Now me, I start off by drawing a solid line, okay? Then I go back and I erase. My solid lines are bad enough as they are, or as they currently are. They're already bad, in other words. And so if I was gonna try to do a dashed one, it would not work. So I just draw a straight line as best I can, then I make it dashed by erasing. And then I have to shade. So 2 ways to shade. 1, read the sign, or 2, pick a test point. Right here, I'll read the sign, and that means I have to shade under because it's less than. So I shade underneath my line. If I chose a test point, I would choose 0, 0. Now, when you choose a test point, if the test point becomes a true statement, you shade with the test point. If it's a false statement, you shade without the test point. So if I chose 0, 0, this would be 0 is less than, 4 times 0 is 0, so it would be 0 is less than -3. That's a false statement. Okay, 0 is not less than -3, so it would mean we would not shade the 0, 0 side, we'd shade the other side, just like we already did. Okay, just showing you both ways to do that. For my next equation, I don't have to do any solving. I just have to start here at 3. And I want to go down 2, right 1. So that's probably where our intersection was. Down 2, right 1, down 2, right 1. And we draw a solid line through this one. It's solid because this is or equal to. Next, we shade. You could pick a test point like 0, 0, at which point you get 0 is less than, you get 0 is less than or equal to 3, which is true. Or you can read the sign. The sign says shade under because this is less than. We're looking for our double shaded region. This region is just shaded with the black color. This is not shaded at all. This is just shaded with the purple color. So my double shaded region is right here in the middle at the bottom. This says write a solution and a non-solution. I think I'm going to take that non-solution thing out for tomorrow. Okay. The EOC doesn't really tend to ask you for non-solutions as often, and this is already a big, long test. So choose a solution. A solution is anything in the double shaded region. I would be safe, pick something near the middle, something like 1, -3, or 2, -3, or -4. Pick something down in here. Don't go too close to the lines, okay? So I'll go with that first one, 1, -3. That's a solution to our first problem. Just like the last set, the second graphing problem is more difficult because I have to solve this first equation and because the second equation is a special case, okay? So for this first equation, I have 3x minus 2y is greater than -2. I move 3x over. I get -2y is greater than -3x minus 2. I divide by -2. This is the first time we've come across something like this. When I divide by a negative number, you flip the sign. That's from all the way back in our inequalities chapter. -3 over -2, those don't actually divide nicely. It'd be a decimal. We don't want decimals for slope. We leave them as fractions. But the negative and negative do cancel out to make a positive. And then -2 divided by -2 is +1. So for this green equation, we're starting at 1, going up 3, right 2, or down 3, left 2. We draw a line through this, but this is not an or equal to problem, so it needs to be a dashed line. Okay. And then we want to shade below. Careful, I looked up here. I almost shaded above, guys. We want to shade below. Again, test point always works. If I choose 0, 0 as a test point, my guess is I'm going to shade below it because of the sign. But if I chose it, it'd be 0 is less than. This would be 3/2 times 0, which is 0. So it's 0 is less than 1. That is a true statement. So indeed, I'm shading down below it. Test point said so. Sign said so. Always, always know you can go back and use the test point. Next, we have a little bit of an awkward situation. This is x is greater than or equal to -2. You have to just know that x equals a number, okay, or in this case, inequality. That's a vertical line. Y equals a number is a horizontal line. So this is going to be a vertical line at -2 right here. It's a solid line, okay? A solid line because this is or equal to. And then there's the greater than, which tells me I shade the stuff higher than -2. When I'm looking for my double shaded region, I actually get a very, very large double shaded region here, okay? All of this. This whole thing is my double shaded region. Okay? Everything in there. So when I'm looking for a solution, there's plenty to choose from. Be safe, choose something that's easy to spot. Something way over here like 4, 0. or 4, -2, or